So our next speaker is Patrick Foley. He spent a long time at Intel really building up the core capacity of federated learning for them. But I'm delighted to tell you that he's joined Flower in the last couple of weeks, and he's going to tell you all about the journey that he sees forward for OpenFL and Flower working together. So over to Patrick.
Thank you very much, Nick. Thank you for being with us today at Flower AI Day. So as Nick mentioned, I recently joined Flower Labs as a principal engineer, but up until recently, I was working at Intel, where I was leading the Open Federated Learning, also called OpenFL project. And I'm also the lead of the technical steering committee for the project. And I'm going to be here telling you today about how you can bring your OpenFL workloads into Flower. So just a bit about OpenFL and what it is. So OpenFL is a real-world federated learning framework. We started in 2018, and I'm lucky enough to be joined here by former major catalysts for the success of the project, Tony Reyna and Shin Hans, for starting with these real-world use cases where we wanted to understand what the practical application of federated learning was in the real world. So we partnered with the University of Pennsylvania starting in 2018, and federated learning had really just been coined as a term by Google a few years before. And we wanted to establish, is it possible to apply federated learning to medical imaging? And the answer was yes, and it's very successful. So we were able to demonstrate that a model trained in a federated context was able to demonstrate 99% of the accuracy versus a centrally trained model. And so this was a collaboration between researchers, and that really gave the proving point to go and scale this as a real open source development platform and try to productionize a lot of the work. So over the last years, I've been serving as the lead architect for the project, and we've had quite a bit of success with it. We've become a top 5 federated learning framework that's out there, and I've been working closely, as Nick mentioned, with Flower Labs throughout the last couple of years on the standards and interoperability side of things, because this is really a new paradigm for training AI models. And we saw that there's really going to be a need for researchers to develop their workloads once, and then have the ability of scaling those across frameworks. Starting in 2023, OpenFL went from being an Intel project to a Linux Foundation project. The reasoning for this is that we wanted it to be owned by the wider community, and it's governed today by members from Intel as well as Flower Labs. So Daniel is on the technical steering committee for it. The FATE project, which is another federated learning framework, as well as Leidos and Indiana University, where there's carryover from the original UPenn collaboration. So what is some of the success that we've had with OpenFL? Where has it been deployed? I'm happy to say that in the last 2 years, OpenFL had the privilege of being the first federated learning framework of running on the International Space Station. When I say running on the International Space Station, this wasn't a simulation that was just running on the ISS as a prepackaged workload. This was truly a real federation where there was a model being trained on the ISS, there was a model being trained on Earth, and we had to deal with the loss of connectivity between the ISS and Earth at the same time. And so having the capabilities in the framework being able to handle this kind of network loss was really a major factor in the success. The type of machine learning use case that we were working on came out of another research collaboration with the Frontier Development Lab. And we were trying to establish whether it was possible to confidentially train on astronaut health data and understand, based on the radiation that those astronauts were subject to, would they go on to develop cancer or not? And so we were able to determine that there was actually a causal link between a previously understudied gene that had been ignored in the research, and this has now gone on to be a target for further evaluation. Some of the other successful deployments that we've had. I mentioned the collaboration with the University of Pennsylvania. The outcome of a lot of this work was scaling to truly the world's largest healthcare federation. So we brought together 71 research institutions across 6 different continents. So this was truly a worldwide effort to train a brain tumor segmentation model. And the outcome of this research, which was published in Nature, was that the federated model was able to demonstrate a 33% improvement for operable tumor regions versus a model trained on public data alone. So this is really a testament to what happens when you get access to a private data, but then you preserve the privacy and only embed the learnings into the model itself. OpenFL has also been used in generative AI for drug discovery. So we worked with AbbVie over the last couple of years, and they had this situation where they have silos internally within the company, and they are in the business of trying to come up with as many candidates to take forward for clinical trials, but it takes a lot of effort to go through this. So using diffusion models, which you've probably heard a lot about through the image creation, it also applies to generative AI for molecular discovery, and we were able to successfully apply this to reduce toxicity in those drugs that became candidates for further research. And then actually back about 5 years ago, we had worked with the Montefiore Health System on COVID-19 severity prediction. And this is actually a use case that was released to production across 6 of their hospitals in the New York area. So with all of the success that OpenFL has had, we really want to be in a position where we can take this work forward and be able to deliver these real-world, innovative, and impactful use cases for not just now, but for the future as well. And so in the last couple of months, due to changes in the companies that are backing the OpenFL project, it's no longer under active development. So while it remains a top 5 federated learning framework that's out there, it doesn't have the developers that are backing it and maintaining its use. So this brings me to why I'm here today, which is that while there's no developers that are working on OpenFL, we want to be able to carry forward those workloads and this really impactful work that's been done over time. And so I'm very pleased to announce that we're providing a path for the OpenFL community to now become part of the Flower community. And so what that means concretely is that Flower will become the endorsed federated learning framework that OpenFL Workloads will be recommended to go to after the project shuts down. And there will be a migration guide that's put in place for how users can easily bring their OpenFL workloads and bring those into Flower. But the motivation for Flower ahead of maybe other federated learning federated learning frameworks that are out there, we've had a long-standing collaboration, as I harkened back to earlier. I've been working with Daniel and Nick and Tanner, the Flower leadership, for the last 3 to 4 years, and we have a similar ethos in terms of what federated learning should be. It's about research. It's about how you can actually deliver this research to industrial use cases. And it's really a natural progression of taking forward this work into something that has become the most popular and useful federated learning framework that's there. The other big reason is vendor neutrality. So Flower has demonstrated that they are willing to work with all kinds of hardware vendors. And this is really what makes sense, because you have different hardware that can be deployed, whether it's on Earth in certain environments or on the ISS, where you have a very different set of hardware. And Flower has been in the position where they want to just make sure that federated learning can work everywhere. And that's what makes Flower so popular today. The other big reason is that there's a thriving research community behind Flower and strong industry adoption. So you've heard a bit from Daniel already, but there's a lot of really interesting industry impacts from Flower, and a lot of the real world use cases that I talked about earlier with OpenFL, those are starting, you're seeing those land in a really big way in the wider Flower ecosystem. The other big shared value between OpenFL and Flower is a strong commitment to security and privacy. So confidential compute is a big part of what I was working on back at Intel with OpenFL. Flower has, of course, worked with different hardware vendors like NVIDIA, Intel over the years, and they share a commitment to the value of confidential compute and being able to securely train your models, and also be able to encrypt them along the way as they're being transmitted between different actors. Flower, unlike other frameworks that are out there, has the proven ability to scale to very large federations. So they've pursued the cross-device aspect of federated learning in addition to cross-silo. And what that means is that they've had evidence of supporting thousands of simultaneous nodes at a time. And this will become more and more important as we want to scale this real-world research that's been done into a lot of consumer applications over time. And Flower is also the best positioned to help transition users from research into the real world. So I talked about a lot of the existing collaborations that Flower has had over time, but with the Flower framework, it's easy to go from a simulation with the simulation runtime to the deployment runtime with really just one step. And then the other big piece of this is that Flower is committed to bringing in those OpenFL features that have been unique to us back into Flower to make sure that our customers have a home in this new ecosystem. So this means that those loss of network events that could have taken place for NASA and the ISS, these are the type of capabilities that we'll be bringing into Flower, and you can expect to see really interesting collaborations and really the best of both of our work coalesce over time as a result. So getting to the transition timeline, starting 2 weeks ago, I've been reaching out to many of the people in the OpenFL ecosystem and letting them know that OpenFL will soon be shutting down, that Flower is going to be the new home, and there will be this migration that happens. We've already gotten some strong responses around this. There will be an official GitHub announcement that is released October 15th, recommending Flower as well as providing a migration guide that I referred back to earlier. And then starting December 31st, OpenFL will officially be archived. So there is a clear progression here of this transition from the OpenFL ecosystem into Flower. So for those of you who have worked with OpenFL in the audience, either in person or online today, who want to bring your workloads into Flower and reach out and work with me personally on making that happen, please scan this QR code and I'll be happy to work with you further. I want to thank everyone who's been part of the OpenFL journey in making this such an amazing piece of work and one of the highlights of my career. Also to the Flower community for having such a welcoming spirit, both for researchers as well as others who may be framed as competitors. And we're excited to keep going on this journey together. So thank you very much.